Take a look at this. This is a dye-sensitized solar cell, and it produces electricity using simple blackberry juice. Hi, I'm Neal Abrams. Welcome back to the lab. Today we're going to look at how to make a dye-sensitized solar cell using some pretty simple materials in the lab. So let's get started. There are a few things we need to make the dye-sensitized solar cell. The first is some conductive glass, as I have a piece right here. We also will need some titania, which is a white powder we'll talk about in a few minutes, and a redox electrolyte, which will help complete our circuit. The first thing we're going to do is make a paste using the titania. This titania is going to act as a conductor for the electrons. I've placed some titania paste inside this beaker, and we're going to make a slurry using some nitric acid, dilute nitric acid. The slurry should be the consistency that it's a little thicker than water, but thinner than paste. So I'm going to add some of the acid and slowly stir until we get the right consistency. You can see now that we have a smooth paste with no lumps. It's a little thicker than water, but thinner than paste, more like the consistency of white paint or so. After we have the paste, we need to make a border on our glass so we can apply the paste. So we're going to start with a piece of indium-doped tin oxide glass. This looks like normal glass, but it actually has a conductive coating on it. To find out what side the coating is on, we're going to use a multimeter set to resistance. If we have the correct side, we'll see that the resistance goes to 0. So let's take a look. And we can see that the resistance now says 0, so we have the correct side facing up. Using some tape, we're going to make a 4-sided border around the piece of glass. 2 pieces of tape on 3 of the sides, and 1 piece of tape on the 4th side. After all the taping is completed, we'll have a cell that looks like this. We're going to then take that cell, that piece of glass, and apply our titania paste. We only need a small amount of the paste, so we're going to collect some on the spatula and place it right at the top. We can apply enough that it can go further on the glass and coat the whole piece, and we'll just wipe the excess off. We'll then use a stirring rod to press and push the paste across the glass. And that looks pretty good. If for some reason you have some streaks or it looks not quite as smooth, you can use the stirring rod and pull back again until you get a nice smooth paste. Once that paste is dried, and it will take about 5 or 10 minutes, you'll have something that looks like this. It is dry, but it still has the tape border on it. We then have to take that cell and heat it on a hot plate. So you can remove the tape and place it on the hot plate. Once it's on the hot plate, it should heat for about 10 minutes, at which time the small pieces of titanium dioxide will anneal together or slightly melt and strengthen the material. And you can see it has a nice white border on it. At this stage, we're ready to dye the cell so it can actually absorb sunlight. To dye the cell, we're going to use blackberry juice today. I've extracted some blackberry juice, and all we need is a small amount of the juice to place right on top of the cell. As we place it on to the cell, the juice will get absorbed onto the surface of the titanium dioxide, forming a nice purple compound. This should take about 5 or 10 minutes for complete absorption. We're going to then take the cell and rinse off the dye, first using deionized water. And you can see that nice purple color is left behind. That purple color is comes from a compound known as an anthocyanin. Those anthocyanins are found in raspberries, blackberries, cherries, pomegranates, and all of those fruits can actually make this type of cell. I've done this final rinse with isopropanol. The isopropanol acts as a drying agent to remove any of the water that's present. You can then use a simple Kim wipe to blot the surface dry. And we have our working side or anode of the cell ready to go. The other part of the cell that we need is a back electrode or counter electrode. The counter electrode is also another piece of glass, just like the front electrode, except that's been coated with a small amount of graphite from a pencil, just colored in. That pencil lead acts as a catalyst to keep the reaction going. We're going to take that pencil side and put it down on top of the cell. If you're unsure about the conductive side, just use your multimeter. We're then going to take the cell and clamp it together using some binder clips, making sure to offset the edges so we can apply our multimeter probes. At this stage, the cell is ready to go, except that there's no conductivity. We're going to add the conductivity using a redox electrolyte made of iodine and potassium iodide. Just put 2 or 3 drops at the top and squeeze the binder clips in and out a few times until the dye and redox electrolyte are mixed together. At this stage, we have a working solar cell. So let's take a look. Taking our multimeter again, we're going to change it to millivolts. Depending on what type of multimeter you have, the way you change it will be different. To make the measurement a little easier, I'm going to apply some alligator clips to the probes. And then those alligator clips are going to get connected to the cell. As I connect it to the cell, we should start to see a voltage. And in fact, as I move it into the light, we see over 250 millivolts right now. And that's just using room light. So as you can see, we were able to make a dye-sensitized solar cell, a cell that produces electricity just using simple blackberry juice.